Hi there! In this video we continue to do a practice. Previously we created our training pipeline, so-called, which means that we created the feature engineering step and we created model training. After, we saved our feature engineering in the utils so that we can import this function, and we also saved our module. So in this video we are going to test our data, our raw data and preprocessed data for data stability, data quality and data drift, because that's first steps of our pipeline, right? We need to make sure that we loaded correct raw data and we preprocessed it well. In this case, we use simulation data, right? So it's not like we really derive those data from logs, but in your real batch or online models, you are going to actually load data from the right sources. And in this case, of course, it makes more sense. Now we are going to use the same function, fetch OpenML, to load our data, but anyway, we are going to apply some checks right to this new loaded data. So first of all, let me create a title and import all the libraries, and we will proceed to the checks. Here we go, and let me import libraries. Now let's load our data. And I want to recreate our dataset so that we have training dataset, reference dataset, and production simulation data. Basically, I'm gonna do very same split as we did before, assuming that our data is ordered by time, like it would be if we could derive data from the real logs, and I'm gonna split it like top-down. First 5,000 rows goes to the training data. Second 2,000 rows goes to reference data. It's kind of the first successful production batch of data. And all the rest data goes to production simulation data, which we later are going to split into batches. And as we agreed before, our batch size would be 2,000 rows. We can think of it like that our call center can process daily like 2,000 clients. I don't know if it's close to the reality or not. We do not have such an experience. But to me, big enough call center, 2,000 clients sounds reasonable. Yep. Now we've done everything we need to do before we actually go to checks, and now let's see how we can check our raw data. I would create the following label. And let's proceed. Basically, you can customize any test suite using Evidently, because Evidently allows you to create the test suite containing many different tests, right? So you can use something that we already implemented in Evidently and we have like really a lot of tests. Or you can implement your own test and use it inside of test suite as well. But together with individual tests, we also have a test preset, which are well-combined tests which suit for tackle the specific problem. And I'm going to introduce to you first data quality and data stability test suites, because it helps us to assess the quality of raw data. As we discussed previously, there are different ways how you can generate test conditions, and test conditions are quite important for alerting, right? So that we can see whether our tests are passed or not. And now in this case, we are going to use the reference dataset because it's a very fast way to just get started with test suites. So let me create my data stability test suite and apply it to our raw data. And I believe you will be surprised how fast actually we can implement that, because we already imported from evidently preset and test suite, and now we just need to run the calculations on top of our pandas data frames. Now I need to run my calculations, and here I need to specify the data. So as reference dataset, I'm gonna use my reference data. And as a current data, I can go for the first batch of data from my production simulation dataset. And for doing that, I'm going to just use my dataset. Let me fix the batch size quickly. And I'm going to just go for first batch. Luckily, I can do it with a very short construction. And finally, I need to somehow analyze my suite, and I'm going to show the results right here in my Jupyter notebook. This is why I use method show with mod equal to inline. So let's run that. Literally 3 lines of code, and you can see our first test suite. So you see that actually we did not really did a lot of actions here. We just selected the data stability test preset, and it created for us 44 tests, so quite a lot. 38 were successful and 6 were failed. So what we can do, we can observe first of all what tests do we have here. It's like test for a number of rows, test for a number of columns. So we can see that the number of columns are equal for reference and the production data, right? And that's exactly what we expect for our column, so it makes sense. As for about a number of rows, it really depends. If you expect for some reason that your reference data and batch of data have equal size in terms of rows, well, that's good test. If not, you'd better pass here your custom condition, right? This is why actually it allows you to pass some custom conditions for tests. Column types, again, all the column types are the same between the reference and the current data. Share of missing values is equal to 0, and etc, etc. So if you're interested, you can really go through all the successful tests and see what we tested and just be happy about the successful tests. But I would rather go to the failed test, and I would group my test by status right here. Then I will go for failed tests, and here we have all my 6 failed tests. So I can see that 3 of them are share of out of range values, and I can see that, well, it's quite a lot. So almost all of the values for my V10 column are out of range. So I can hit the details button and see what's going on here. So with the red color, I have the distribution for this feature for my current data, with the gray one for my reference data, and I can see that they barely intersect. Unfortunately, it's quite hard to tell what it is, because this column name V10 doesn't really help us to quickly grasp the sense of data, but at least you can see that there is this significant light shift right between those data. I believe you could see somewhat pretty similar there for other features. It's V6. No, it's much better here actually, but still there is a shift, I believe somewhere here. You can see that all plots are interactive, so that you can see what's going on here exactly. We can zoom in and explore different regions of our plot, right? And let's go further. Again, that's already share of outlist values here. May, probably it's some feature related to the months, right? Or maybe it months itself. And etc, etc. So that this kind of tests help you to figure out what exactly has changed, because probably if you can assume that our data is ordered in time, that maybe this mean value stability for V10 column, for V11 column or where I had my months. Yeah, it's for V11 column equal to May. Maybe that's not a problem because, well, if we split data by batches and time is going, right, and months changes, maybe that's okay, because previously we had, for instance, I don't know, April or March, and now we have May, maybe that's okay, right? But for other columns, it can be a problem, and this is why you can actually decide yourself how exactly you might parameterize your test by conditions or what test to add here. So presets are a really good quick start, right? But later it's better to customize your tests to your own data, knowing your conditions and knowing the specifics of domain area and the way you use your machine learning model. Now that's what you can achieve here. So I would say that I'm pretty happy with the tests. It's not really convenient to analyze it with help of the raw data on top of raw data, because I really do not remember the meaning of each column. But anyway, I can proceed with the other type of checks, and I would go for data quality now, and again on top of raw data. Okay, for data quality again we have 38 tests, right, and only 4 failed tests in this case, so that's very good. Let me directly go to the failed test. So we have 4 failed tests, again for V11 column, right, some highly correlated columns, share of most common value for V1 and for V13. So it would be very interesting if I could recall the meaning of my features, but now anyway we can see that the share of failed tests is not that high, so probably we can proceed with that. But if your tests are critical and you see that you have, for instance, like share of missing values or somewhat like this failed, it's better to stop here and go back to the loading raw data procedure and see whether you have any issues or maybe just some technical errors there. And we're gonna proceed, and actually you could limit yourself with these 2 suites or maybe only one amount of these 2 test suites. And if you want, you can also test, for instance, data drift on top of raw data, because it also can tell you something. So let us just, for the sake of curiosity, run data drift test for our raw data as well. We already know that we will have some drifted columns because this May-June issue, right? And maybe we have some more drifted columns. Let's see. And first of all, we have this share of drifted columns test, which is passed because the share of drifted features is like 5 out of 17 and threshold is like 30%. So it's not like the whole data set has drifted, and I can see what exactly drifted. So our target is not drifted, well, that's good. And when it comes to features, 6 features drifted. Yeah, actually we shouldn't have the target here yet, but that's just because we imported the whole data set from the source, right? In the production case, you probably won't have any class or target data here, but I believe you can just skip that part. Well, then you have like individual drift for different columns, for all the columns. And again, you can check only the columns where you have this drift. You can go for details and explore the distributions here. And basically here it's pretty clear that all the drift goes from the months, right? So previously we had only May in our reference data, now we have May and June, and drift is detected, but probably that's not the problem, right? So that's not the reason why you should like stop the whole production pipeline and try to fix something. This is why it's important to first of all decide on what checks you want to have in your test suites and whether you need to even have this kind of test in the first place, right? Then it makes sense to split your tests between critical and non-critical and maybe mark such tests as non-critical. And finally, you can always move from the individual test, and here I mean tests for individual features, to like aggregated tests for the whole data set, like share of drifted features, to avoid such false alerts. But anyway, it's all very easily customizable so that you can play around with that. And well, we have 4 failed tests, so that's 3 more columns, which is this V13, I'm not gonna guess what it was, V10, oh, something interesting going on here, and V1, okay, definitely different distributions. And finally V6, right? But it's really hard to tell what's going on here. This is why I would rather move my data drift test to the process data. At least I have the correct names here and I can understand what's going on with my data drift and feature distributions. So what I'm going to do next is to pre-process my data. And guess what? The logic of implementation will be very similar. Let us check the data drift for pre-processed data. For doing that, before running off test suite, we need to actually pre-process our data, and we would need to do it for our reference data and production simulation data as well. So let's do that. Luckily, previously we already implemented this function, feature engineering I mean, and now we can just import it from utils and call it right here. And now let's recalculate our same test suite data drift one, but for processed data. Let me run this. And well, we have huge report containing individual drift tests. That's a lot. And I would go rather for the summary because it's written that we had 50 tests. 44 were successful, 6 were failed. So our share of drifted columns is fine, and then we can explore all individual drifts. And the good news is that now we can group it by status again, open up our 6 failed tests, and now we see the correct names, right? So lucky we can actually understand what's going on with our data. So we can see that we have drift for last contact months, May and June, which makes total sense because, well, that's the seasonality-based data. We have drift for day feature, which is kind of okay again. And we also have a drift for age feature, which is kind of weird because we really cannot somehow connect the age with the seasons, right? So let us open up this test and see what's going on here. Well, I wouldn't say that it's totally different distributions, but we can see that here we have some differences. So this is the good insight to go back to data loading or data pre-processing step and see what's going on. Maybe we can consult with our domain experts and they can advise us with that. Probably it was some campaign focused more on the older people, right? Because in the reference we had more young people there, and maybe that's the reason. Maybe the reason is that the previously campaign was focused on younger people, and this is why now we have this shift. So that's very good moment and good place to go and find some insights. Okay, let's continue. We also have some drift for campaign and balance. Very interesting. Yeah, I believe we can connect those with the previous ones, right? So maybe balance is somehow connected with the age, hopefully, right? Or non-hopefully. I don't know whether it's good news or bad. Actually, I just wish everyone had quite a lot of money and be happy with the income. Yeah, so maybe that's the connection. So, okay, that's how we can do that. And actually, no one stops us from having this data drift, data quality and data stability checks be used both before the feature engineering and after feature engineering, or you can decide that, for instance, you use data quality and data stability only for raw data, and there, if everything with data quality and data stability good, you do not reapply the same test suits after feature engineering, but you do apply drift for feature engineering. Or maybe you want to apply all 3 test suites before feature engineering and after. It's all up to you. Finally, I would like to introduce to you a very small thing, which is the summary of our tests in JSON or Python dictionary format, because quite often you do not do such kind of analysis in Jupyter Notebook, right? In most cases, you have some automation, and for instance, you apply some batch models in the pipeline managers, pipeline workflow manager, like maybe Prefect, maybe Airflow, maybe Kubeflow, it depends on what is introduced in your company, right? And if you have some checks integrated into your deck, right, you might want to react somehow if you have not all tests passed, or maybe very critical tests failed, or whatever you want. And in order to be able to run your decks conditionally, you might want to derive the status from the reports itself. And we can perfectly do that. Let me quickly show you. So we have data drift suite, and we can go for different suite formats. For instance, let us go for sdict, because we are going to analyze the output of our suite. So we go for sdict function, right? And this sdict function returns to us this dictionary with the results of each test. I know that you have very nice summary part of our report, so let me just show it to you. And here I have quite short dictionary with several fields, like all passed, total tests, success tests, failed tests, and by status, right? What you can do here is, for instance, create your condition like this. Summary, let's go for all passed, and something like this, right? So if you do conditions like this, you just compare your all passed with true, and if it's false, you can, for instance, stop your prediction pipeline and do something, right? Or maybe generate HTML file or send an alert to your engineer, whatever makes sense for your production model, right? Or maybe you may go for more complicated conditions, like instead of all passed, you can go for what we have. Let me quickly check again. So by status, okay, and then say that if the amount of successful tests is more than 40, then you are happy, for instance. And here is it true, right? So in terms of our pipelines, we can go to next step in the pipeline if our test condition is equal to true. So that's how you specify the conditions for different steps in your pipelines. Now we checked our raw data and our transformed data after feature engineering, and next step would be to assess actually model quality. We are interested in model outputs and in the model error, so in the next video we are going to explore that as well.